Today we will study about the logic gates. There are different types of logic gates. We will see different types of logic gates one by one. First is the AND gate. So an AND gate has two or more inputs but only one output. The output assumes the logic 1 state only when each of its input is at logic 1 state. The output assumes the logic 0 state even if one of its inputs is at logic 0 state. The AND gate may therefore be defined as a device whose output is 1 if and only if all its inputs are 1. Hence, the AND gate is also called an all or nothing gate. And here you can see this is the logic symbol of the AND gate. So, it is a two input AND gate. So, four combinations are possible. 0, 0, 0, 1, 1, 0 and 1, 1. So, if you multiply 0, 0, what will be the output? 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. So, when both the inputs, these are the input, this is the output. When both the inputs are 0, output is 0. 0, 1, output is 0. 1, 0, output is 0. 1, 1, output is 1. So, what is the general expression? A, B, if there are two inputs of the AND gate, if X is the output, we can write X equals to AB. Okay. Next, previously we have seen two input AND gate. Now, we will see three input AND gate. So, here we will be having the three inputs and X is the output. So, output will be A, B, C. And with these three variables, 8 combinations are possible, 8 input combinations are possible starting from 0 to 7. Okay, so these are the binary representations of 0 to 7. 0, 0, 0, 0, 0, 1, 1 is 0, 0, 1, 2 is 0, 1, 0. 3 is 0, 1, 1, 4 is 1, 0, 0, 5 is 1, 0, 1, 6 is 1, 1, 0, 7 is 1, 1, 1. So if you multiply 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1 is 1, right? So with the input variables to the AND gate represented by ABC, the Boolean expression for the output can be written as X equals to A dot B dot C. Okay, and if you notice here one thing, that the output is logic 1 when both the input is 1. Okay, if one of the input is 0, then output will be 0, right? Next, moving on to the OR gate. So, like an AND gate, the OR gate may have two or more inputs but only one output. Okay, the output assumes the logic 1 state even if one of its inputs is in logic 1 state. The output assumes the logic 0 state only when each of its input is in logic 0 state. And OR gate may therefore be defined as a device whose output is 1 even if one of its input is 1. Hence, an OR gate is also called any or all gate. It can also be called an inclusive OR gate because it includes the condition both the inputs are present. So, these are the logic symbol of the OR gate. If we make a truth table for a two input OR gate, 4 combinations are possible for input, and if you notice here one thing, whenever one of the input is 1, the output is becoming 1, right? So, when one of these input is 1, the output is 1, right? And the output will be 0 when both the inputs are 0. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 is 1, right? So, if A and B are two inputs, X is the output. We can write it X equals to A plus B. So if we have three input OR gate, there will be three inputs. We can write it X equals to A plus B plus C. Same as we can have 8 input combinations. 0 plus 0 plus 0, output will be 0. 0 plus 0 plus 1, output will be 1. 0 plus 1 plus 0, output will be 1. 0 plus 1 plus 1, 1 plus 1 is 1. 1. This also 1 plus 1 is 1. 1 plus 1 is 1. 1 plus 1 plus 1 is 1. Right? So, now coming to the NOT gate. Okay, these are the basic gates. AND gate, OR gate, NOT gate. This is also called AND or invert or the basic gates. A NOT gate, which is also called as inverter, has only one input and of course only one output. And it is a device whose output is always the complement of the input. That means if you have this is the logic symbol of the NOT gate. If whenever you whatever input you are giving, it the output will be complementary of the input. If you are giving 0, it will be 1. If you are giving 1, it will be 0. If your input is A, it will give A bar. Okay. Now what will be the truth table? Only two combinations are possible, either 0 or 1. So output will be the complementary. The symbol for a NOT gate operation, NOT operation is bar. X equals to A bar. When the input variable to the NOT gate is represented by A and the output variable is X, the expression of output X equals to A